All right, so I want to start with transformations tonight. We're going to look at the square root function. But from transformations, we're going to start with translations. You need to remember from geometry that they are rigid. It's a rigid transformation. It preserves properties. So we want to be able to take a look at this graph when we're done. But so let's start with this. So my parent function is entered right here. I'm going to start, I've set this so I can only go in increments. Look, I'm going to subtract 1, I'm going to subtract 2. Do you notice that the graph is moving? Oops, come back here. It's moving to the right. Okay, so if I subtract a positive number, it moves to the right. Now let's look right there. I subtracted 4. Now look right here. 1, 2, 3. It's 4 units away. So I take this x coordinate of 1 and I add 4 to get 5. Notice the y value is kept the same. I take this 0 and I add 4 and I get 4, and the y value is 0. Now let me pull this over here, because you know what? If I subtract a negative, I go to the left. And again, it's just moving it. Now let's look at going up. All right, so we want to subtract 3, so that's a movement of 3 up. And we want to, now let's look at this point right here. I have to add 4 to the x coordinate, and I have to add 3 to the y coordinate. Now look at this point. If I add 4, I'm here. If I add 3, I'm here. Look at this one. If I add 4, I'm here, and 3, I'm there. So it's consistent. Now let's take a look at this. So first we need to realize that y, which is the root of x, was translated 4 units to the right and 3 units upwards. Okay? Many of you are going to say, Mr. Isaac, for my graphing calculator, I need to write it this way. Okay, well, let's write it this way, which is, again, look, up 3, we're still going 4. What do you put in here to get 0? I'll put positive 4. So we have an ordered pair on my pre-image, so let's start with what those are. My x-coordinates that make sense are perfect squares, so I'll put those down. My y-coordinates with the square root of these perfect squares. Okay. My domain and my range are both 0 to infinity, where 0 is included. Now, from our graph, we know that we keep the x values and add 4, we keep the y values and we add 3. So here's how I get the new table. I'm just going to add 4. 0 plus 4 is 4. 1 plus 4 is 5. 4 plus 4 is 8. 9 plus 4 is 13. Now we come over here. 0 plus 3 is 3. Don't forget the y like I just did. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3, I hope, is still 6. Now let's look at the domain. Domain is the x-coordinate, so I use this rule. So for the left endpoint, 4 plus 0 is 4. If I add 4 as I'm going further out to infinity, I'm still going to infinity. For the range, 0 plus 3 is 3. I was going to write 0 plus 3 there for a second, excuse me. And if I add 3 to a number that's way out there, it's still way out there to the right, so I'm going to infinity. And our first example is done. On our next video, I'll do a different example.